Yeah, so a very good morning to all of you. So, uh, according to the previous days, the earlier class, uh, we have learned about this preliminaries of this memory interfacing with the 8051 microcontroller. So, was there any confusion or any queries? Let me ask you first. Because this is very important for your semester examination also, end semester examination also. Any query you can ask, otherwise we'll move to the next interfacing part. Okay, so just you can see we have discussed that this was the RAM block because due to the presence of read and write, both things, because in the RAM we can read and write both the things. Okay. Now we are coming to this particular interfacing. Just you can see that here. Can you tell me what is this RAM or ROM? Can anyone tell that?
Sorry, sir, ROM.
Why?
Only read can we hear.
Yes.
Memory MEMR.
So you can see this read only is there. Okay, no write option is there. So obviously in ROM we know that read only memory, because we can this memory block only can read. Okay, so for this we will see that how the interfacing is going on. First we can see this, the size of the ROM is 4K into 8. Okay, so we are writing over the paper just 4K into 8. That means 2 to the power 10 into 2 to the power 2. Okay, this 4K means, so 2 to the power 12. So address lines are needed for to address these 4 kilobytes of memory. How many address lines are needed?
12.
12. So we know that A0 to A15, these are the address lines. So 12 address lines means A0 to A11. Okay, and rest of these A12 to A15, these address lines are used for the chip enable. Clear or not? These 12 address lines are used for addressing purpose, and rest of the address lines are used for chip enable purpose. Okay, to activate the chip. Which chip? This ROM chip. Clear or not?
Clear, sir.
Okay, so we can see we are using A0 to A11 to this microcontroller and this ROM. Okay, so A0 to A11 is directly connected to the ROM from the microcontroller. Okay, and rest of the things we can see this A12 to A15, these four address lines for the chip selection lines. Okay, clear? So here you can see, unlike we are going to the previous slide, just you can see this particular chip enable things have been done with this NAND gate. Okay, but unlike this, in this particular ROM interfacing, we are using, this is for example only, we are using this 74LS138 as decoder. So this is the decoder. So what is the decoder?
Okay, sir. Yeah,
Is yes. Okay, so this decoder is nothing but we can see A, B, C. Okay, A, B, and C. There are three inputs, and Y0 to Y7 there are 8 outputs. Okay, so 3:8 decoder. So in the question, it will be written like interface 4K into 8 kilobytes, 4K into 8 ROM with the microcontroller 8051 using a decoder or using a NAND gate. So अगर NAND gate कहा गया तो NAND gate से करना है, अगर decoder से कहा गया तो decoder से करना है. Clear? And it will also be mentioned that which particular output line should be selected. Okay, like this here Y4 is selected. Clear? So now we are just forming a truth table. Like there are three address lines, that is A, B, C. Okay, and this is Y, this is the output. Clear? Sorry. So when all the things are 0, then Y0 is selected. Now when C is 1, then Y1 is selected. Y2, 0, 1, 1, Y3, 1, 0, 0, Y4, 1, 0, 1, Y5, 1, 1, 0, Y6, 1, 1, 1, Y7. Okay, so this is the thing. Clear or not? This is the decoder selection procedure. Clear? So here we can see to select this Y4, this bit pattern must be followed. This particular bit pattern should be followed. Clear? So now look into the figure. I'm just clearing it all the way. Just look into the figure that A, B, C. Okay, A is connected to A12, B is connected to A13, and C is connected to A14. Okay, clear? And by default, this A15 is connected to G2A bar. Okay, so this is also active low pin. So to enable this pin, we need to we need to connect 0 with this, so that this will be active. Similarly, G2B, these G2A and G2B, these two pins are used for the activation of this particular decoder. Unless these two pins are connected to ground, this decoder will not act, will not give the output. Clear? And VCC is connected to G1. Okay, clear? Now this whatever we are talking about, this A12 to A15, A15 is connected to G2A, so this is the active low, so this must be 0, A15 must be 0. And now if you can see the truth table, to select for selection of Y4, as this is selected, as this line is selected, so A12 must be 1, A13 should be 0, A14 should be 0. Clear? Clear or not? So we are writing the address range. So we are writing from here A15, A14, A13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. So this A15 to A12, these are reserved for this particular chip selection, and rest of the things are directly connected to this microcontroller. Clear?
Yes, sir.
Okay. So we are putting all 0. And here, what will be the bit pattern?
A15 0,
A15 is 0,
A14 is 0,
0,
A13 0,
0,
A12 1.
A12 1. Clear? And as we have discussed it in the earlier class also, that we cannot change this, because if we change this, then the chip will not be selected. अगर एक भी बीट ये A15 से A12 तक एक भी बीट चेंज हो जाए, then this decoder will not be active. Clear? So we cannot change this particular 4 in this case. मतलब क्या है, वो चिप सिलेक्ट के लिए जो जो एड्रेस लाइंस रिजर्व्ड है, वी कैनॉट चेंज दिस. ओके, बिकॉज अगर वो चेंज करेंगे, देन आवर चिप सिलेक्शन विल नॉट बी डन प्रॉपरली. क्लियर? क्लियर और नॉट? Okay, so here also we can see that whenever this chip enable is the active low signal, so here 0 must be there. Clear? Otherwise this ROM will not be selected. So to give 0, this Y4 output is connected with a NOT gate. Clear? So here we can see this bubble 1. This bubble 1 means the complement of the output. Okay. Anyway, so we are coming to the address range. So minimum bit patterns will be all 0 and maximum will be all 1. Okay. So what will be the address range? This is 1 and this was also 1, and this is, if we divide it like this, so it will come like 1 0 0 0 2 1 F F F. So address range this will be 1 0 0 0 H to 1 F F F H. Clear? Clear or not? Any questions you can ask?
Sir, repeat it.
Which part?
Address
Sir,
range.
yes,
Last.
sir. Can you please explain once more?
Just see this A15 to A12, these 4 address bits are used for the chip enable thing. Okay, so chip enable, we cannot change this chip enable, and the A11 to A0, these 12 bits are used for addressing the ROM. Clear? So for addressing the ROM, the minimum address that can be addressed by these particular 12 bits will be what? All 0, the minimum address range, not range, the minimum address, all 0, and maximum address will be what? All 1, because this is the binary one, either 0 or 1. 0 is minimum, 1 is maximum. right? So all 0 to all 1. So we are just converting it to its equivalent hexadecimal numbers. Clear? Now it is clear.
Yes, clear.
Yes, sir.
Okay. So we are going forward. Now Rishabh Kumar. Rishabh Kumar.
Yes, sir.
Now tell me that how many address lines are needed to address this ROM, this particular ROM.
Actress.
8K into 8 RAM. Sorry, ROM.
16, sir.
How that is possible?
Sorry, sir. Address line 0 to 7, 8 lines, sir.
Mm-hmm.
Sir, address line is A0 to A7 means 8 lines. Sir.
8 lines. So can you show me your copy by sharing the screen? Whatever you have written in the earlier case.
No, sir, I didn't written it.
Okay. Don't have the copy with you.
What, sir?
You don't have the copy with you right now.
Sir,
You are
I
doing
have,
the
but I didn't written it.
okay. So whatever you have written, the last thing you have written, what? What was the last thing you have
Sir,
written in your copy regarding this subject?
uh, sir,
Okay, but you are doing the class, but without a copy, without
yes, sir.
pen, you are just listening to a radio, right?
No, sir. I revised it from sir LMS portal, sir.
Okay.
What you
So
uploaded
you
on
you
that.
people, Shalini Priya, are you there? Shalini Priya, you are you there? Shalini, I can't hear you. Shalini, you have unmuted yourself, but I can't hear you. You are not there. I need to remove you. Tanisha, are you there?
Yes, sir.
Now tell me how many address lines are needed to address this 8K into 8 program ROM? Do you know that how many address lines are needed? Can you show me your copy?
So I have not written anything.
At the very beginning, you have not written anything.
Yes, sir.
From the beginning, very beginning of this class, you did not write anything because today is the 15th class.
No, sir. Today I have not written anything.
And the last day? What about the last day? Tanisha, unmute yourself.
Yes, sir.
What about the last day?
So not written.
Very good. Vinod Kumar Rajak,
Yes,
so how many address lines are needed?
sir, 13, A0 to A12.
Okay. Jyotsna Nag,
Yes, sir.
so how many address lines are needed?
Oh.
Jyotsna, can you tell me how many address lines are needed to address this 8K into 8 ROM?
Sir, 12.
How 12? Can you show me your copy? You can show your copy by turning on the video. Okay. Amisha, can you tell me? Amisha, are you there?
Yes, sir.
So tell me how many address lines are needed? Okay. So here we can see, I'm telling everyone that whenever you are sitting for a class, carry your copy, keep your copy, and write whatever is taught in the class. Okay, for every
Sir,
subject, for this subject.
I
only.
have written, sir.
Yeah, but not all the people are writing. I'm seeing maximum of the people are not writing, and they are sitting in the class without a copy, without a pen. This is not at all expected from them. Anyway, so for this particular ROM interfacing, we can see this A0 to A7. Let us draw it first. Let us write that 8K into 8. That means 8K is 2 to the power 10 into 2 to the power 3. So this is 2 to the power 13. So 13 address lines 13 address lines are needed, okay, to address this particular ROM. So 13 address lines means A0 to A12. So here, what are the address lines that are used to chip enable? What are the address lines?
A13 to A15.
A13 to A15.
Very good. So here also we can see this A, just a minute. Yeah. So here also we can see this is the A0 to A0 to A7. I'm just writing over it. So A0 to A7, these are connected to this particular ROM with from the microcontroller, and A8 to A12 is directly connected. Now, why this latch is given? Because we know that AD0 to AD7, these are multiplexed. So they needs to be differentiated. That means the address needs to be separated with from the data, so that this particular latch IC is used, that is 74LS373. So by this we are getting A0 to A7, these address lines to this program ROM. Okay. Similarly, 8 to A12, these are directly connected to, because a higher order address is not connected with the I mean not multiplexed with the data. Okay, so that this A8 to A12 is connected. Okay, now this chip enable, you can see this output enable that is directly connected to this PSEN bar. Okay, now here if we are using this program strobe enable, if we can remember the function of this PSEN bar, okay, that is program strobe enable. If we enable this, then this particular interfacing doesn't need any address lines to be selected, because we are not using any NAND gate or any decoder. Okay.
Sir, can you please repeat it again?
Hello. Hello.
Yes, sir.
Yeah. Whatever you have told, actually some network issues there.
Sir, can you please repeat PSEN
Yeah.
select chip?
Okay. So for the program strobe enable, that means whenever this pin is activated, then from the ROM, the program can be traced. Okay. Now, suppose in this particular program ROM, as this is written, that this is the program ROM. Program ROM means in this ROM, some program is stored. And when the ROM is needed, because when the particular on-chip ROM is getting over. So we have also discussed while discussing the architecture of microcontroller 8051 microcontroller, that if a program length is 5 kilobyte, okay, we cannot store it 4 kilobytes in on chip and 1 kilobyte in external chip. We need to write the total 5 kilobytes of program in the external ROM, because on chip is only 4 kilobytes. Okay, so to trace the program to जो प्रोग्राम ROM में लिखा हुआ है उसको पढ़ने के लिए, जैसे कि हम लोगों को एक चाबी लगता है ताला खोलने के लिए, this PSEN bar is the key here to open the program. Okay, this whenever this PSEN bar is going to this output enable, then this particular program ROM understands that, okay, I need to give the output to the microcontroller. Okay, now what is the output? Nothing but these addresses. Okay, and this particular data, you can see this data, they are transferred between the microcontroller and the ROM. as you know, this data is bidirectional and address is unidirectional. So address can be one direction to another direction only, but data can be transferred in both the directions. So finally, we can conclude that that's this PSEN bar. This enables ROM to transfer the data, to start the transfer of data and address within microcontroller and the program ROM. Is it clear?
Yes, sir.
Okay. So here also we have already told that in 8051, 8031 or 51 EA, that is if you can remember, this EA bar VPP, that is external access, and VPP, this external access, that means that means external access means whenever an external ROM or external RAM is connected with the microcontroller, then EA, that must be grounded. And as this particular 8051 is not having any on-chip thing, then this particular microcontroller needs to connect the external RAM or ROM totally externally. Okay, totally externally means there is no on-chip ROM. But in case of 8051, you can see in case of 8051, 4K of on-chip ROM is there. So the total addressable area is total addressable range that can be addressed by the 8051 microcontroller is 2 to the power 16, because 16 address lines are there. So 2 to the power 16 means how many? 2 to the power 16 means 64 kilobytes. So if 4 kilobytes of ROM is available in the on chip, so off chip how many needed? 60 kilobytes. Clear? This is written over here. Okay, clear or not? Okay, any questions?
So please repeat it once again.
Wherever we have discussed the architecture of this particular 8051 microcontroller, this 8051 microcontroller is having 64 kilobytes of addressable range. Okay, now look into the copy. The 8051 has 16 address lines. Okay, so how much the address range can be addressed? That is 2 to the power 16.
2 to the power 16.
Yes, so 64 kilobytes. But in 8051, only 4 kilobytes of on-chip ROM is available. Okay, so in maximum, how many ROM can be, how much size of the RAM should be that can be connected with this particular 8051 microcontroller, because it is 64 minus 4, that is equals to 60 kilobytes ROM, that is off chip. Off chip means bahar se lagana pad raha hai, that is not included in the 8051 chip. Clear? यही दिखाया गया
Yes.
डायग्राम में. This 0020 FFF, that is 4 kilobytes of RAM is available in this particular 8051 IC, and rest of the things can be connected externally. Similarly here also 8 kilobytes of on chip ROM. On chip is 8 KB. Okay, so we can connect 56 kilobytes of external RAM. Clear? So this is the concept. Okay.
Yes, sir.
Okay. Now do this quickly. After recording after recording your attendance, you can leave the class.
Sir, the time is exceeded.
Sorry.
Sir, the time is exceeded.
Okay, just a minute. Now do this. Please share this with your classmates, because they may not having this kind of things.